Question 2. Last year, an online store sold a large number of computers. 55% of the computers were made by company F, 30% were made by company G, and 15% were made by company H. A random sample of 3 customers who each bought a computer from this store is chosen. Find the probability that the 3 customers bought computers all made by different companies. Now, if all were made by 3 different companies, we can get the first computer. This is how we are going to attempt this one here. We can get the first computer. The first customer can pick a computer which is made by company F, then the other one company G, then the other one company H. Then we can also have the first one now picked is F, then H, then G. We can also have G, then F, then H. Then we can have G, then H, then F. Then we can have another one. The first one picked is H, then F, G, and then lastly H, then G, and then F. In other words, we are arranging F, G, and H. This is the same as 3 factorial, which is 6. So all of these ones have gotten the same probabilities, like probability of F is 0.55, then for G is 0.3, then for this one is 0.15. So all of them, we are going to have that multiplication, okay? But then they are appearing 6 times. So you will find when they have written something like this, 0.55 times 0.3, that is the probability for this one here. And then for H is 0.15. And then they put something like this times 3 factorial. 3 factorial is for the arrangement of all of these ones. If it is not 3 factorial, then it is the same as saying times 6. Okay. So all of this together, what we get? 0.55 times 0.3 times 0.15 times 3 factorial. Then we get our answer as 0.1485. 0.1485. Usually we write our answers to 3 significant figures, but I don't need to write this one to 3 significant figures because it's a terminating decimal. Okay, so you can leave your answer just like that. A random sample of 12 customers who each bought a computer from this store is chosen. Find the probability that fewer than 10 of these customers bought a computer made by company F. Now this is a binomial distribution because the number of customers is known, and this one is a repeated process. So because it is a repeated process and n is fixed, then this can be a binomial distribution. So our n here is 12. Then P, they said bought a computer made by company F. So if we check company F here, it was 55%. So that is our P. And then the remaining will be the Q, the probability of getting the failure. So this is 0.55, and then the Q is going to be 0.45 when you subtract 0.55 from 1. Okay, so they want us to get probability of x less than 10. That is probability of x is equal to 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. But that is wastage of time. Instead of doing all of that, why don't I just say that we get 1, then minus probability of, since 10 is not included here, then I say x greater or equal to 10. Now I include it here. So here we can then have 1 minus probability of, this is x is equal to 10. Then we have x which is equal to 11, and then x is equal to 12. Okay, so using the formula for binomial, we shall have inside here 12 combination 10, the success is appearing 10 times, so the probability is 0.55, then 10, and then the failure will be appearing 2 times. Remember, when we add these two, we get the n here. Then plus, this will be 12 combination 11, and then 0.55 to the power of 11, and then 0.45 power 1, then 12 combination 12, which is a 1 times 0.55 power 12, but then 0.45 is to the power of 0, which is also 1 there. Okay, and then what we can do here is to put this in the calculator, this one and this one. Then after adding all of them, we subtract from 1. So what can we get from here? So we are going to have 12 combination 10, then times 0.55 power 10, then times 0.45 squared. So I'm going to do like this. That is one bracket, then plus I open another bracket which has 12, then combination 12 combination 11 is the same as 12, then times 0.55 power 11, and then from there we multiply by 0.45 power 1, then plus, we shall come to this one here. The last one is 12 factorial, 12 combination 12, that is the same as 1. So we just put 0.55 power 12, just that one there. And we are getting 0.0421419826. So then we subtract that one from 1. So 1 minus 0.0421419826. Then when we subtract it from 1 minus the answer, we get 0.95785 80174, 0.95785 and of course to 3 significant figures, this one will be 0.958, and that becomes our answer. Next, a random sample of 140 customers who each bought a computer from this store is chosen. Part C. Use a suitable approximation to find the probability that more than 24 of these customers bought a computer made by company H. Now, here the moment they say a suitable approximation, that means we are going to approximate the binomial to the normal distribution. So if we are finding the probability that more than 24 of these customers bought a computer made by company H, that means we are going to consider the numbers which are greater than 25. 24, we have 25, 26, 27, 28. You are finding all of these probabilities up to when you get to 140. That one becomes so hectic. Okay, so what we need to do is to approximate this binomial to the normal, and there are two things that we must do. Number one is to find the mean. Okay, mean, which is given as mu, we get it as NP. Now, we are using the binomial to get the mean of a binomial distribution. It is NP. Then after that is the one we are going to use in normal distribution, because when we are dealing with normal distribution, we need to have the mean and then the standard deviation. So N is 140, then the P. Bought a computer made by company H. So for company H, the P is 0.15. Then the Q, it was 15%. That means the Q is going to be 0.85. So we multiply this one by 0.15. And then the standard deviation is equal to root of variance, and variance is NPQ. So this will be root of 140, the P is 0.15, and the Q is 0.85. So what do we get here? This one, I'm going to leave it in a square root. Okay, I always use 140 times 0.15. This one gives us 21, and then 140 times 0.15, then times 0.85. This one gives us 17.85. So I'll come here and I say 17.85, and then this one is 21. Then another thing we need to do is to carry out continuity corrections. Okay, we carry out continuity corrections. Why are we carrying out continuity corrections? Because we are moving from discrete data and we are going to continuous data. Normal distribution deals with continuous data. So if I have my numbers here, this is 24, then the next one is 25, then this one is 23, then we have the lower bound and the upper bound of 24. This will be 24.5. When you round off 24.5, it no longer gives you the 24, but it will give you the 25. You see? So that is the upper bound, and then the lower bound here is going to be 23.5 here. When you round off this one and all the numbers that are here, they will all give you the 24. Now, this is the region for the 24. In IGCSE, actually, you are taught to find these lower bounds. They used to tell you maybe a number like this, and then there's a complete statement, and they put something like this. Then less than or equal. Maybe this one is about the number of the people, then less than, then they put this. But this one is less than because we are dealing with the numbers that are less than here. If you take this 24, it is not going to give you the 25 when you round off, but the numbers that are below that 25 will give you that number. So that is why this one is less than. And then here we have less than or equal because all the numbers that are here, they will give you this 25. Okay, all the numbers here, I mean this 24, even the 23.5. Okay, so that is why we have something like that. Now what we do, here we are supposed to find probability of x greater than 24. This one means, by the way, we are supposed to pick either this one or this one here. So how do you know that you're supposed to pick the lower bound of that number or the upper bound of that number? This is what you do. You are supposed to get those numbers from a number whereby when you round off, the value you get is greater than 24. Don't you think it has to be the 24.5? That when we round it off, the number we get is above the 24. So we shall get 25 and then the rest of these ones here. So meaning we shall subtract a 0.5 from here. I mean we shall add a 0.5 from here, and then we get x. This one approximates to probability of x, which is greater than 24.5. Okay. Now, to simplify these continuity corrections, this is what you're going to do. If they have given you greater than or equal, if they have given you greater than, you are going to add a 0.5. If they have given you less than, you are going to subtract a 0.5. If they have given you greater than or equal, subtract a 0.5. If it is less than or equal, you add a 0.5. So to memorize these ones very fast, for greater than, add a 0.5. Then for less than, subtract a 0.5. Then there or equals, you do the opposite. It's a plus, here it's a minus. It's a minus here it's a plus. As simple as that. And if you don't do these continuity corrections when you are approximating the binomial to the normal, they don't proceed to mark you. So they just end there. Now next, of course, we are supposed to standardize. When we are standardizing, z we know is equal to x minus mu, then over the standard deviation. So this one is going to be probability of where there is x, I put z, then greater than. Our x here is 24.5, then minus the mean, which we got as 21 up here, and then the standard deviation is this one here. So we divide by the square root of 15.85. So I can simplify the numerator here. It is going to be z greater than 24.5 minus 21 is actually 3.5. Then divide by the square root of 15.85. Now, you can write this one as a decimal and you give it to 3 decimal places, because when we go to the normal distribution table, we must use z is given to 3 decimal places. So they want greater than. Now this value here is this way on the right of the mean. The standardized mean is 0. So let me say that is z1. So they want this one here, the greater than. Now, since the other normal distribution, the table they give you has only for less than, then you will say 1, total probability is 1, then minus for this one. So you go and look out for the value of this to 3 decimal places. The probability you get there, then you subtract it from 1. Okay. However, we can use a calculator here. This is what you can get. You will come to your calculator here, and then if it is FX991ES, this is what you can do. So you press mode, then you go to start, that is 3, and then that will come on the screen. You just press SC, that button SC, and also I think it has something like off. So you press it, then start comes on your screen. Then when start comes on your screen, you press shift, then you come to 1, button number 1. That is where we are having start. Okay, so you press it, then you go to option number 5, which has distribution. So you press 5, and then P, the P you are seeing there is for less than. The R you are seeing there, those are the most important that we need. The R is greater than. So I will press 3. That is for greater than. Then I will press 3.5. Then I divide by the square root of 17.85. And you press equals. So that is the answer you get, 0.20375. 0.20372. And then to 3 significant figures, 0.204. 3 significant figures. Now the calculator gives 5 decimal places. I have a calculator on the phone which gives even up to 12 decimal places. So to ensure uniformity in the answers, they always tell us to put our answers to 3 significant figures. So this would be the answer.